Hello everyone. Today we are going to learn chapter 10, linear system of differential equations. So 10.1, introduction to system of differential equation. So we do only one question in 10.1 and then we move on to 10.2. So I want to combine 10.1 and 10.2. All right? Okay, so we did that application about the tank, about the salt solution before, right? This section is about two tank connected. Then how do we set it up? That question about the differential equation. Okay, so we have a tank A here and tank B, they connected. Yeah. Then we set Q sub 1 prime, rating for tank A, and we take away rate out for tank A. And then we have Q sub 2 prime equal to rate in for tank B, and we take away from rate out for tank B. All right? Okay, so we have one question here. I just want to explain to you. All right? So the pages is a little bit messy. Take a look. Whoa. Yeah. Okay, so let me read. Two tanks are interconnected, and tank A contains 60 grams of salt in 30 liters of water. Yeah, 30 liters of water. Okay, now tank B contains 70 grams of salt in 40 liters of water. Okay, now uh, we set it up this one as initial condition. When x of 0 is 60, then that's 60 grams of salt. And we have tank B, y of 0 equal to 70 grams of salt. All right? Okay, now let me read. A solution of 5 grams per liters flows into tank A at a rate of 5 liters per minute, while a solution of 3 grams per liters flows into tank B. The rate is 7 liters per minute. They are well mixed. Okay, the tanks are connected, so 8 liters per minute flows from tank A to tank B, while 3 liters per minute flows from tank B to tank A. An additional 12 liters per minute drains from tank B. Yeah. Okay. Letting X represent the grams of salt in tank A, and Y represent the grams of salt in tank. Set up system of differential equation. Excuse me. Excuse me. Hold on one second. Okay, so where did I stop? Okay, I think Y, right? So Y, Y represent the grams of salt in tank B. So we want to just set it up. We don't want to solve at this time. Just set it up. Okay, so set up the system of differential equation for these two tanks. Yeah. That's why we did the earlier rating for tank A, rate out for tank A, and rating for tank B, rate out for tank B. Okay? So we're gonna set it up, the equation. Okay, so we have an initial condition earlier, right? So when t equal to 0, then x of 0 equal to 60, we start with when t equal to 0, and Y tank B starts 70 grams of salt. All right. Okay, so I drew tank A, tank B in a connected. So the solution of in the tank A, 5 grams a liter flows into, right? And the rate is 5 liters per minute. And solution of 3 grams per liter, and that rate 7 liters per minute, right? Get into the tank B, right? They mix well, and 8 liters per minute from tank A to tank B, and from tank B to A, 3 liters per minute. And then there's additionally drain 12 liters per minute. That is rate, right? Okay. All right. So how do we set it up? So we set it up dx over dt differential equation, right? So we have a rate in for tank A, take away rate out for tank A. Yeah. That's the dx over dt. Yeah. All right. So rate in. So we have a solution and times rate and plus a flow from tank A. No, flow not from, right? Flow in tank A, right? Yeah. Okay. So the number, because they have the same number, so I put the units so that you don't get confused, right? So 5 grams, the solution, 5 grams per liter. So here, right? No, that's the, see, that's why I put the unit. 5 grams per liters, and we times the rate, 5 liters per minute, yeah, flows into tank A, right? And we have from the tank B, right? From the tank B, 3 liters per minute. And then we don't know how much salt. So we say the Y because from the tank B, Y over, and then the 40 come from liters of water. So we don't know how much salt remain from the water 40 grams per minute. So that's the unit. All right. So these two from the tank B. Yeah. The tank A has the solution with the rate. Make sense? Okay. Now we take away rate out from the tank B. I'm sorry, tank A. Even right? Tank rate out from the tank A, right? Okay. So they say that 8 liters per minute from tank A to tank B, right? And then we don't know how much salt out from the 30 grams per liter water, right? So initially they have that. Yeah. Yeah. So yeah. So grams. So that grams come from, right? And the liters. Yeah. That's better, right? So let me fix that. So how much salt we don't know. And then the liters come from here, right? So water. Yeah. And also here too, this is grams for salt. We don't know how much. Weigh it out. And then that's the from the water, 30 liters initially. We have that, right? Okay. So we understand? Okay. Now, if we combining everything, so we have a 25 plus 3 over 40y minus Simplify. 8 divided by 30, right? So it's a 4 over 15. So we have x. Yeah. Okay. So let us do the y over the t. Okay. So we are using rating for tank B, rate out from tank B, right? Okay. Same concept. We have a solution times rate plus a flow in, flow from tank A. Okay. Then we should make a flow from tank B here too then. Yeah. Since we have overflow in tank A, that's fine too, right? Yeah. In, so in or flow from tank B in that case. Flow from tank B. So let me write down just B2. Yeah, because no space. Okay, so there will be, if we are using the application on top, so we have 3 grams per liter. That's a solution we start with. They say that, not start with, they say that 3 grams per liter flows into tank B, and the rate is 7 liters per minute, right? So we wrote down there, solution times rate, yeah. And then flow from tank A, so there will be 8 liter per minute flows from tank A to B. And then we don't know how much salt in from tank A and from the 30 liters water, right? So the units, we don't know what's grams for salt. And then from the 30 liters from water, right? Okay, now rate out from tank B, right? So 3 liters per minute flows from tank B, and additional 12 liters per minute drain from tank B. So 3 plus 12 there. Yeah. And then we don't know how much salt drain from there, right? Out of 40 liters water, right? Yeah. Okay. Now everything all together. So we simplify. So we have a 21 and simplify 8 out of 30. And it's a 4 over 15x. And then negative, it's a 15 there, 15 over 40, which is a 3 over 8. Y, right? Okay. Now, so let me change this is grams per liter, right? Yeah, grams per liter. Everything okay, right? So we have this one for dy over dt. So we have dx over dt, and we have initial values, right? Okay, so we done for 10.1. So let us do 10.2. So 10.2, it's about linear system of a differential equation. Yay. So I believe you took linear algebra. Yeah. Okay, so this is a form of linear system, right? So we have first order system, yeah. Okay, then we have y prime sub 1, y prime sub 2, and so on until y prime sub y prime over y prime sub n, yeah. And then we have a sub 1 1 over t y sub 1 plus a sub 1 2 over t y sub 2 and so on, and then f sub 1 over t, right? Okay, now we've seen this one before, right? So we have just y in the case, sub 1 without derivative, the prime, right? Then that's just a linear system we learned from the linear algebra course, right? But then we have a prime, so it's a differential equation. So we have only the derivative of first one, so first order system of differential equation, all right? Okay, so this one, which is a linear system, which is first order system, right? We can express as matrix form here. Okay, then we're using this one as a matrix form. We're using this one, only the coefficient, right? As a matrix form. And then we're using the variable here, y sub 1, y sub 2. Then we have another function notation here, right? Okay. So this one, we can make an equation form, which is y prime equal to a over t, because all the coefficient we made a over t, and then this is a y, and plus f over t, right? Okay. Now, we knew that this is a coefficient, right? And then f is the function. They have more than function, forcing function, yeah? And it's continuous. And then if this one equal to 0, then homogeneous. Otherwise, non-homogeneous, yeah? All right. So let us do this. Right. The system y prime sub 1 equal to y sub 1 plus 2 y sub 1 plus 2. Oh, made a mistake, huh? Should be 2 sub 2, right? Yeah. Not the 1, right? Yeah, I fixed that. Plus 2e to the 4t. Okay, so we want to make a matrix form like this, right? Okay, so first one we make like that, right? And second one we take the only the coefficient, and then we're using the variable y sub 1, y sub 2 here, right? And then this is the e function there, right? Okay, so how do we write? So there will be, this is a vector form, prime, which is the same as y prime sub 1, y prime sub 2, right? Okay. So there will be, we have the coefficient 1, 2, 2, 1, then vector y. So this is the same as y sub 1, y sub 2, right? Then how do we indicate this one? Coefficient. Then same function e to the 4t. Make sense? Yeah, so we can express this way. All right. Okay, next one. So we want to convert u second prime minus 4u prime plus 5u equal to e to the negative t into a system of first order equation by letting x equal to u, y equal to u prime. So basically first order equation, right? So that means x prime, y prime. So we have to find x prime, y prime. Make sense? Okay, so we have um we have x equal to u, y equal to u prime, right? Then what is x prime? Which is u prime, right? What is y prime? Which is u prime, right? Okay. Then look, since since x prime equal to u prime, then what's the u prime? We get y, right? So we have y. Done. Yeah. Does x prime equal to y? All right. What about y prime? How do you find the y prime? So from the equation, so we have equation, copy. Now we have, okay, then what's the y second prime? It's a y prime, right? So this is y prime minus 4. What's the u prime? U prime is y, right? So this is a y. Oh, this is a y. And plus 5. What is a u? U is x. Yeah. So u is x. And equal to e to the negative t. Yeah. Okay. Now we want to solve for y prime because the question said find y prime, right? So solve for y prime. Yeah. Then everything move to the other side. Done. Yeah. Okay, so y prime equal to e to the negative t plus 4y plus negative 5x. Yeah. Okay. Uh, that's it, right? Yeah. You okay? All right. So let me y prime like that. Okay, the last question for this section. So we have this form. Uh, you want to write down this form too? So let's try that form, right? So if we have x prime, y prime, then so we have to make x, y, right? So in that case, 0, in that case, 1, In that case, -5. In that case, it's 4, right? And plus, oh, there is no e to the t, right? So, yeah, so this is 0 and 1 for e to the -t then, yeah? So like earlier form, we have that too, right? Okay. All right. So this one we have rewrite the matrix form as a single second order differential equation for x. Okay. Single second order means that the goal x second prime equal to something equation. Okay. All right. So let's do that. Oh, let us make an equation form first. Yeah. So the first one will be x prime equal to, we do this way, right? So 3x plus y, that's it, right? And then y prime equal to uh -3x, -4y. Yeah. Okay. Then we want to solve for second prime, right? So equation 1, equation 2, from equation 1, yeah, then we done, right? So we derivative, right? So let me write down everything here. Copy, derivative. So we get x double prime equal to 3x prime plus y prime. Done, right? Okay, but then we cannot leave y prime there. So means that we want to answer in terms of everything is x, right? Okay, then y prime. Then we can substitute from equation number 2, right? Y prime, yeah. So we have x double prime equal to 3x prime plus y prime. Copy, right? So from equation 2. Okay, then once again, we cannot leave it y there, right? All right, then since we got this equation from equation 2, let's solve for y from the equation 1, right? So we don't want y there. Make sense? Okay, now from note, solve for y from equation 1. So equation 1, copy. Okay, so we get y equal to then x prime minus 3x, right? All right, so this one we substitute into there. Yeah. Okay, let's do that. So we have from here, so x second prime equal to 3x prime plus a negative negative 3x minus 4 and y uh, x, x prime negative 3x same color. Okay, so there will be equal to 3x prime minus 3x and distribute, so negative 4x prime plus 3x. Yeah. Okay. Hold on 1 second. Let me double check because I don't get the same number. Yeah. Yeah, I made a mistake here, right? So it's a positive 12x. Yeah, positive 12x. Okay, then notice that we combining prime with prime, so which is negative x prime, and negative 3 plus 12x, which is plus 9x, yeah? So that is answer. All right. Okay. Thank you for watching. I will see you in the next video. Thank you. Bye.